Welcome to lesson 23, and the topic of today's lesson is the tangent problem. So we start looking at the tangent. What's your goal today? I can identify the role and importance of slope and use it to solve problems that involve corresponding information. Now, we are going to revisit the concept of slope from grade 9. We're going to start looking at it in a little bit different light as we move through this particular unit. So the first thing I want to take a quick review on is the linear function, because a tangent line is obviously a line, so we're going to be working with y equals mx plus b, or f of x equals mx plus b. So if you recall from grade 9, your b is your, some of you'll know it as y-intercept or initial value, or y-translation. So if you think of your translations, it really moves the line up or down on the graph. M, at this point in time, if to ask you what M is, most of you would tell me slope, which is correct. But I'd want a little bit more, and I would hope that most people could then tell me after some digging, it's a measurement of the steepness of a line. Steepness of a line, and that's really from still a grade 9 definition. Now, some of you might have another definition for me, and this comes from the MHF, some might not, but the interpretation of slope, and this might be the definition that you are actually thinking, and if you are, that's great. Really, what I'm wanting, I'm going to move your thinking process from measurement of steepness of a line, and we're going to start using the words rate of change. And if your definition that you were thinking when you're watching this video involved the rate of change, you're actually more correct, or right on the path that I'm looking at heading down. So it's the rate of change of y with respect to the change in x. So we're looking at how is y behaving, how is it changing as our x value changes. So just a quick run through here on how slope is calculated, because it is going to become important for us again. So for any people that had me in the grade 9 course, you've seen this exact portion of the note. We're really looking at, if we're looking at it from point A to point B, we know that the coordinates, just move my A and B since they're not well placed. Point A is at x1, y1. Point B would be at x2, y2. And underneath, we know that slope is equal to rise over run, and that's what we really started with in grade 9. So I'm really going back to the basics here. This was our rise. This is our run. Then we moved you into saying that that could also be represented as delta y over delta x. So rise, so then we move to delta y and delta x. And then I asked you, well, what does delta y and what does delta x represent? Well, delta y is the change in y, so you end up with y2 minus y1. What's the difference from your final point to your end point? So y2 minus y1, x2 minus x1, and that gave us our final version of the slope equation. And there we are. So there's a quick review of slope and how it's developed, and it's going to, like I said, it's going to become more important. We're going to actually revisit this again and move it into sort of a calculus perspective. All right, so tangents. Let's talk about that for a second. When a line crosses a curve, so what we're going to do over here in the grid, you just need to draw a cubic graph, a cubic, not because that's the only one, it's just the one I'm choosing. Okay, so you're going to draw some cubic, and this is our function f of x. So I'm naming the graph. So when a line crosses a curve and intersects it twice, all right, so I'm just reading over here. So when it crosses it twice, that line segment is known as a secant. And again, coming from the advanced functions course, you're going to be familiar with the terminology. So if you have a line that crosses twice at point A and point B, you have a secant. And probably some of you are associating, and I have some space over here, our secant. What do you associate that with? And I'm hoping most of you are saying average rate of change. Average rate of change. And yes, it's coming. What you did in the grade 12 advanced functions is coming back, and we're redoing a lot of your functions course, except it's only going to take me half the semester to cover what it took almost your whole semester to do. And that's the advantage with calculus. Now, when a line touches the curve at one point, so if we're looking at the curve touches the curve at one point, we know this as our tangent line. So again, shouldn't be anything new here. So go to the purple, only touches at one point. I'm going to say it's right there. I'll call it point C for consistency. And there is our tangent line. Now, what do we associate tangent with? And everyone in here should be saying instantaneous, I don't know how to spell it. It's a bad day. Instantaneous rate of change. All right. Very, very important. And you know what? 99% of the time, that's what our focus is going to be. There's going to be a couple average rate of change questions, but calculus, the focus is instantaneous rate of change. Now, from this point on, I call average rate of change AROC, and I call instantaneous change IROC. So AROC and IROC, it just saves me a lot of writing. So AROC, average rate of change, IROC, instantaneous rate of change, or Warren's favorite car. So calculus at the bottom here, and this is really the most important statement for us, is calculus is the study of mathematics that determines the slope of any tangent line or the equation of any tangent line. So that's all we're doing. This entire course, all we're going to be doing in calculus is finding slope. That's it. That is the calculus component. Calculus of the MCV4U course. So it's just like grade 9. Okay? All I did in grade 9 in the linear unit was we found slope, and that's all we're doing. So for the next 2 months, you will be finding slope. So how tough can this be? And the answer is it's actually not that bad. I'm just trying to scare you a little bit. Okay, we're into final examples here. I have 2 examples that I want to go through. And based on the time, I should be able to get through them both. The first one, determine the equation of a line that has a slope of 1. So I'm going to start writing down information I'm given right away here. So I know slope is 1. We're looking for the equation of a line. So underneath that, I guess, I'm looking for, you know what, I'm going to go with function notation, just in case there's multiple equations. So I'm looking for an equation of a line. So determine the equation of a line. So that's the second piece of information, slope of 1, and is tangent to the curve f of x. So I have to go back. We got a pen over this, so let's make this g of x, because f of x is given 4 minus x minus 2 squared. So what am I looking for? I am looking for the equation of a line. All right. So final answer, I'm going to kind of work it at the same time here. So final answer, I want g of x. G of x equals mx plus b. Now what do I know? I already know that this slope, or this line has a slope of 1. So g of x equals 1 x plus b, or x plus b. So I just need to find a y-intercept. How am I going to find a y-intercept? Well, I'm going to draw a picture here because I'm looking at the curve of f of x. So underneath, I'm going to look at this function, and I'm going to ask myself, what type of function is this? And hopefully most of you are saying, this is a parabola. And I know it's a parabola because it's squared. It's opening down because a is -4. And I know that the vertex for this parabola is at 2, 4. All right. That would be excellent if you know that. 1, 2, 1, 2, 3, 4. And it's opening down. So I'm just giving myself a sketch. I know that the line that I'm looking for, that tangent line, has a slope of 1. So I'm going to say that's a slope of 1 right there. So my tangent line has to just touch my curve. So I'm going to anticipate it's going to be there somewhere. So what does that tell me? Well, guess what? In order for this to occur, the two graphs in question, our tangent line, T, and our parabola, P, they only meet at one point, so we're looking for the intersection of f of x and g of x. So in the rough work then, so again, this final answer, I'm going to keep it off to the side. It's just kind of helping me know where I was heading. So I need to know a b value. So therefore, up here, f of x has to equal g of x. And that's because of this statement right here. A tangent only meets at one point. We want to know the point. So doing a substitution, 4 minus the x minus 2 squared equals x plus b. So we're going to have to go ahead and solve this. So unfortunately, we're going to have to do an expansion here. So I'm going to do 4 minus, I'm doing the FOIL, minus 4x plus 4 equals x plus b. 4 minus x squared plus 4x. Be careful with that distribution. Okay. I want to collect like terms. So I'm going to move things to the right side because I want x squared to be positive. So I would have positive x squared. I'm going to subtract 4x from both sides, which would mean I would end up with negative 3x. I have 4, take away 4, so that's 0. So all I'd be left with is plus b on this side. All right. So how many answers do we want? How many solutions? Because what do we have in front of us? How many solutions do we want? We have a quadratic equation here. Do we want? So here's a quadratic equation. And we know that for a quadratic equation, it can produce no answers. It can produce one answer. It can produce two answers. And for this particular question, we only want one answer because it only touches one. So we want one answer. Still, if you go back to your knowledge of grade 10 or 11, for that to occur, the discriminant b squared minus 4ac must equal 0. So doing our substitution, b squared, so negative 3 squared minus 4. Our a value is a 1, and our c value is the b term. So we need to solve that. So we end up with 9 minus 4b equals 0. 9 equals 4b, or b equals 9 over 4. So taking that information and going back up to where I was, therefore, g of x has to equal x plus 9 over 4. So that gives us the equation of a tangent line that has a slope of 1, and we now know the y-intercept. All right, so there is our final answer. Now I'll go to the next video to finish up the second example.